The question we are solving now belongs to test series 11. It is of control system subject. In specific, it belongs to Bode plots. As per the question, the Bode magnitude plot of a control system with open loop transfer function g of s multiplied by h of s is as shown in the figure. The Bode magnitude plot has an initial slope of minus 20 dB per decade and it has a magnitude of 24.1 at 2 radians per second. From 2 radians per second on, it decays at minus 40 dB per decade and it has a magnitude of minus 12.05 at the point marked. And from this point, the Bode plot decays at a slope of minus 20 dB per decade and at the point marked, it has a magnitude of minus 20.05. And from this point on, the Bode plot decays at minus 40 dB per decade. We need to find g of s multiplied by h of s approximately from this data. From this data, we can say that as the initial decay is minus 20 dB per decade, the system is type 1 system. And also we see that the slope is minus 20 dB per decade between point A that is marked and point B that is marked, and point A corresponds to 0 comma 20 log k to the base 10 and point B corresponds to 2 log 2 to the base 10, that is the x-axis point, and y-axis point is 24.1 dB. From this we can say that the slope is 20 log k to the base k to the base 10 minus 24.1 divided by 0 minus log 2 to the base 10. This is equal to minus 20, and upon simplifying this we can say that k is equal to 32. So we got the information as the system is type 1 system. We got the constant k as 32. Now let us analyze the line from B to C. The point C is marked as shown and let the corresponding frequency be omega 2. So similarly we can say that C corresponds to log omega 2 to the base 10 and the corresponding magnitude is minus 12.05. From this we can say that the slope is equal to log 24.1 plus 12.05 divided by log 2 to the base 10 minus log omega 2 to the base 10, which is equal to minus 40. And upon simplifying this, we see that omega 2 is equal to 16 radians per second. Please note that the point 2 corresponds to a pole due to the reason that from 2 radians per second, the Bode plot decayed at minus 40 dB per decade, and the point C corresponds to 0 due to the reason that from C on, the Bode plot decayed at minus 20 dB per decade. Similarly, upon marking this point as D and upon finding the slope between C and D, we can say that minus 12.05 plus 20.05 divided by log omega 2 to the base 10 minus log omega 3 to the base 10 is equal to minus 20, minus 12. And we already got that omega 2 is 16 radians per second. So upon simplifying, we see that omega 3 is 40 radians per second. So from this we can finally say that the open loop transfer function is g of s multiplied by h of s is equal to, please note that omega 3 corresponds to the point D. K, that is 32 multiplied by the 0, which is at 16 radians per second, that is 1 plus 0.0625s divided by poles at omega 3 equal to 40 radians per second and 2 radians per second. So this can be written as 1 plus 0.5s multiplied by 1 plus 0.025s. Please note that as the system is type 1 system, there is a factor s here. So from this we can say that we got the k value as 32. Due to the initial decay of minus 20 dB per decade, there is a value of s, and due to the line between the points B and C, the term corresponds there is a term corresponding to 1 plus 0.5s in the denominator, and due to the points C and D, there is a term in the numerator which can be written as 1 plus 0.0625s. Due to the line from D, there is a point that is there is a term called 1 plus 0.025s in the denominator. From this, we can say that we can get the open loop transfer function of the given control system as shown. Hence, the correct option which represents the open loop transfer function is C.